A dark matter breakthrough, photosynthesis on Mars, and smelling inside VR? As always, we're diving right into the world of scientific research. Welcome to the Science Hangout. Researchers at the University of Toronto have made a groundbreaking theoretical breakthrough that may explain two long-standing mysteries in astronomy: the nature of dark matter and the large-scale structure of the universe, known as the cosmic web. They propose that dark matter, responsible for 85% of the universe's mass, may truly consist of ultralight particles called axions, first postulated by the Peche-Quinn theory in 1977. This hypothesis could address the clumpiness problem, which refers to the surprisingly uniform distribution of matter on cosmic scales. The existence of axions, if confirmed through future observations and experiments, could be the most significant discovery of this century. Dark matter, which is invisible and does not interact with light, is currently studied only through its gravitational effects on visible matter. The theory suggests that axions, described as fuzzy due to their wave-like behavior, could have wavelengths larger than entire galaxies, thereby influencing the distribution of dark matter. The researchers analyzed data from the cosmic microwave background relic light from the Big Bang and galaxy clustering data. Comparing these datasets, they observed reduced clumpiness in the distribution of matter, supporting the presence of axion dark matter. Computer simulations further confirmed the alignment between axions and the observed patterns. Future research will center around large-scale surveys to map millions of galaxies and gain precise measurements of clumpiness. The researchers also aim to compare their theory to direct observations of dark matter using gravitational lensing, a phenomenon that measures the bending of light from distant galaxies. Understanding dark matter is essential for developing a comprehensive theory on the universe that reconciles gravity and quantum mechanics. Detecting axions could provide insights into the string theory of everything, a prominent theory in physics with a very much sought-after answer. Researchers at the University of Warwick have been developing sustainable technology to harness solar power in space, with the goal of creating life support systems for use on the Moon and Mars. In a study published in Nature Communications, they explore the use of artificial photosynthesis devices, semiconductors, that mimic the process plants use to convert sunlight into energy. These devices have the ability to generate oxygen from water and recycled carbon dioxide, similar to how plants sustain themselves on Earth. By utilizing these systems in space, researchers hope to improve the efficiency and sustainability of long-term space travel compared to current energy systems, such as those used on the International Space Station. Needless to say, efficient and reliable energy sources are crucial for space exploration, and this energy could be used to power rockets, oxygen production, and carbon dioxide recycling. The ample availability of sunlight in space makes it an ideal resource to tap into. Funded by the European Space Agency through the Open Space Innovation Platform, this research represents an important step towards harnessing solar power through artificial photosynthesis and paves the way for more sustainable and efficient energy use for production in space missions, while also providing valuable insights into optimizing solar cell performance on Earth. On the topic of generating electricity, engineers at the University of Massachusetts Amherst have found a way to transform almost any material into a device capable of harvesting electricity from the humidity in the air by creating nanopores smaller than 100 nanometers in diameter on the material's surface. They can generate a charge imbalance similar to that found in a cloud. The researchers are calling this the generic air-gen effect, which allows for the continuous and predictable extraction of electricity from the air. Previously, the researchers had demonstrated the ability to harvest electricity using protein nanowires grown from the bacterium Geobacter sulforeducens. Now, they have expanded this concept to include any material with nanopores. The size of these nanopores is crucial. The holes need to be smaller than 100 nanometers due to a parameter known as the mean free path. The distance a single molecule of a substance, in this case water in the air, travels before it bumps into another single molecule of the same substance. Due to the minuscule size of each pore, water molecules encounter the edges of the pore frequently as they traverse it. Consequently, the upper section of the layer experiences a higher number of water molecules carrying electric charge compared to the lower section. This disparity in charge distribution, much like the charge imbalance found in clouds, results in the upper portion accumulating a greater charge relative to the lower portion. Essentially, this process establishes a battery-like system that remains operational as long as there is humidity present in the atmosphere. The potential applications of this technology are vast. Electricity harvesters could be made from various materials to suit different working conditions, making them adaptable and cost-effective. Additionally, unlike other renewable energy sources such as wind or solar, which rely on specific conditions, these harvesters can operate continuously, day or night, in any weather. Moreover, the scalability of the technology is impressive. Multiple layers of these electricity harvesters, each thinner than a human hair, can be stacked together to increase the energy output without occupying much space. This means that the air-gen devices could deliver kilowatt-level power, making them suitable for widespread electrical utility usage. In an attempt to test the capabilities of AI language models, researchers from TU Delft and the Swiss Technical University EPFL have designed a tomato harvesting robot by collaborating with ChatGPT. In their study, published in the journal Nature Machine Intelligence, the researchers sought to explore the extent to which AI can contribute to the engineering design process and the risks it may pose. In collaborating with ChatGPT, they gained valuable insights, suggestions, and expertise outside of the researcher's domain, helping them identify the most economically valuable crop to automate and making practical recommendations like using a silicone or rubber gripper to prevent tomato damage, as well as opting for a dynamic-soled motor for optimal robot control. The researchers found the collaborative design process to be positive and enriching. Although it required a shift in their roles as engineers, they acknowledged that extreme scenarios where AI provides all the input for robot design may not be feasible or desirable due to the potential for misinformation and bias. AI language models are designed to generate the most probable answers, which highlights the need for professional verification of their output, as well as continuing to utilize the tomato harvesting robot in their robotics research. The researchers intend to further investigate the capabilities of AI language models in designing new robots and the autonomy AIs have in developing their own physical structures. New research from UCL and Italy's National Research Institute for Geophysics and Volcanology reveals that the Campi Flegrei volcano in southern Italy is increasing in its likelihood of erupting. The study, published in Nature's Communications, Earth and Environment journal, utilized a model of volcano fracturing developed at UCL to analyze earthquake patterns and ground uplift. The findings indicate that parts of the volcano have been stretched to the brink of breaking. Although this progression towards rupture doesn't guarantee an eruption, it obviously raises concerns. The volcano has experienced periods of unrest over the past 70 years, such as numerous small earthquakes and significant uplift, with the coastal town of Pozzuoli raising by nearly 4 meters. The researchers emphasize that their model, which incorporates the physics of rock fracturing, has accurately predicted the volcano's behavior since its initial application in 2017. The Campi Flegrei volcano is home to approximately 360,000 people. The recent unrest, characterized by ground uplift and persistent small earthquakes, is likely caused by the movement of fluids, including molten rock and volcanic gas, beneath the surface. The researchers intend to apply their model to other volcanoes that have reawakened after long periods to establish more reliable criteria for predicting eruption likelihood. This shift from statistical forecasting to fundamental principles applicable across multiple volcanoes marks an important advancement in eruption prediction. The researchers note that the effects of the volcano's unrest since the 1950s have accumulated over time, potentially leading to an eruption preceded by relatively weak signals, such as reduced ground uplift and fewer earthquakes. While an eruption is not inevitable, the volcano's current tensile strength is estimated to be about a third of what it was in 1984. A team of researchers from the City University of Hong Kong and Beihang University has developed a wireless, skin-integrated olfactory feedback system that can release various odors through miniaturized odor generators. The goal of this technology is greater immersion into virtual and augmented reality experiences, with experiments showing its applications in 4D movie watching, medical treatments, and online teaching. For example, the system can enable users to experience virtual environments with different fruit fragrances or aid amnesic patients in recalling lost memories through odor perception. Traditional odor-generating technologies are often large and confined to closed areas of bulky VR headsets. To address this, The researchers created a wearable olfaction feedback system with wireless and programmable capabilities. They designed two devices, a small patch-like device with two odor generators that can be mounted on the upper lip for rapid olfactory response, and a flexible face mask with 9 odor generators capable of providing numerous odor combinations. The magic of the odor generators lies in a subtle heating platform and mechanical thermal actuator. By heating and melting odorous paraffin wax, different odors of adjustable concentration can be released. The system allows for rapid response to burst or suppress odors and precise control over odor concentration. It is easily accessible, biocompatible, and supports long-term utilization without frequent replacement or maintenance. The researchers plan to further develop a next-generation olfaction system with faster response times, smaller size, and a higher integration density for VR, AR, and mixed reality MR applications. The study, titled Soft Miniaturized Wireless Olfactory Interface for Virtual Reality, was published in the journal Nature Communications. Japanese researchers have discovered a new way to activate G-protein-coupled receptors by triggering shape changes in the intracellular region of the receptor. The study, published in the journal Nature, contributes to the development of new drugs with reduced side effects and improved patient outcomes. GPCRs play a crucial role in relaying molecular signals, and about 1/3 of existing drugs target them. This new process allows for the design of drugs with fewer or no side effects. The researchers focused on a bone metabolism-related GPCR called the human parathyroid hormone type 1 receptor. They used cryo-electron microscopy to reveal the 3D structure of PTH1R and the G protein bound to a message molecule. By synthesizing a non-peptide message molecule called PCO371, which interacts directly with G protein subunits, they found that PCO371 activates the receptor from inside the cell. Unlike traditional drugs that activate GPCRs from the extracellular side and can cause side effects by activating multiple signaling pathways, PCO371 specifically activates only the G protein pathway and does not trigger B-arrestin, thus reducing side effects. The team's findings provide insights for designing drugs with enhanced specificity and offer potential treatment for various disorders such as osteoporosis, obesity, pain, and neurological disorders. This research opens up possibilities for developing small molecule-based drugs that act on specific molecular pathways, providing more targeted and effective treatments.